Hi students, welcome to Sankalp Learning Classes. In this session, we'll be discussing 1 mark questions of chapter Vector Algebra. So in total, you will have 8 mark questions from this chapter. That is, you'll get 3 1 mark questions. Okay, might be MCQ and fill in the blanks. Okay, so in total, 3 1 mark questions will be there. Then 1 2 mark question and 1 3 mark question. So in total, you will have 8 mark questions from this chapter Vector Algebra. So in this session, we'll be dealing with 1 mark questions of the chapter. Okay. So before that, we'll discuss some of the important concepts in the chapter vector. Okay. So we have studied about different types of vectors, right? So that is given in the first slide. That is, we have studied about equal vector, collinear vector, then unit vector, right? What do you mean by a unit vector? A vector having magnitude 1, right? Magnitude unity or magnitude 1 is known as a unit vector. Then what do you mean by an equal vector? When can you say that two vectors are equal? When the magnitude and the direction of the vectors are equal. And I hope that you understand the difference between a scalar quantity and a vector quantity, isn't it? Scalar quantity means it has only magnitude. It doesn't have any direction, right? It doesn't depend on direction. That is known as, such quantities are known as scalar quantity. And the quantities that has magnitude as well as direction. Okay, magnitude as well as direction, such quantity is known as vector quantity. Okay, so in this chapter, we'll be dealing with vector quantities, their algebra, that is finding the dot product, finding the cross product of the vectors, etc. Okay, so first of all, we need to know the concept of equal vectors. When can you say that a vector, two vectors are equal? When both the vectors have the same magnitude and same direction. Okay, both should be equal. The magnitude as well as the direction should be equal. Okay, such vectors are known as equal vectors. And what do you mean by collinear vector? When can you say that two vectors are collinear? If they are parallel to each other. Two vectors are said to be collinear if they are parallel to each other. All right. So moving on to our next slide. So this is actually how will you find out the magnitude of a vector that is given there. Okay, the magnitude of a vector is vector. Consider the vector OP. Okay, consider. You can see here, consider the vector OP, and the magnitude of vector OP is equal to root of x square plus y square plus z square. What is this x, y and z? These are the components. These are the scalar components of the unit vector ijk. Ijk are unit vector and x, y, z are their corresponding scalar components. And how will you find out the magnitude of the particular vector? It is nothing but root of x square plus y square plus z square. Okay, I hope everybody knows all these concepts. Just we are quickly reflecting these topics in order to solve the problems. Okay, so and if you are given a point in a space that is ABC, then we can say that ABC is the direction ratio of that point. Okay, direction ratio. And what is the direction cosines along the vector OP? We know OP means it is a position vector of the point P. Okay, if you are given a point in a space, you can find the position vector of that point, right? That is known as OP. Okay, so that is the direction cosine along the vector OP is equal to A by root of A square plus B square plus C square. Similarly, it is the second is B by root of A square plus B square plus C square, and C by root of A square plus B square plus C square. All right, now moving on to the next topic, that is addition of vectors. Okay, how will you do? How will you add two vector? How will you add two vector if you are given vector A and vector B? How will you add it? You just add their corresponding components. That is, you add the components. First, you add the components of vector I. Okay, unit vector I. That is A1 and B1 are the components. So you add A1 plus B1 into I. Then A2 plus B2 into J. Then A3 plus B3 into K. So how will you find out vector A minus vector B? Vector A minus vector B is A1 minus B1 into I plus A2 minus B2 into J plus A3 minus B3 into K. You subtract the corresponding components, then you will get the subtraction of two vectors. Okay, so and you have studied about triangle law of vector addition. What is this triangle law of vector addition that you have studied here? If you consider points A, B and C, A, B and C, and let this be vector AB. Okay, let this This is vector AB. Okay. This is vector AB means it is in this direction. Okay. And this is vector BC. Vector BC means it is in the direction B to C. Okay. So directed line segments are vectors, right? Line segments. AB is a line segment. When you give a direction to that line segment, it will become a directed line segment. And this directed line segment is the vector. Okay. So AB is a vector. BC is a vector. Then we can say that according to triangle law of vector addition, if you add AB plus BC, okay, if you add the vectors, vector AB plus vector BC, then what you will get? You will get vector AC. Then you will get vector AC. Okay, so you understand the importance of the direction of vector AC. It is here like this. Okay, it is from A to C. The direction of the line segment AC is from A to C. Okay, so AB is like this, the direction, then BC is like this, the direction, then AB plus BC, you will get the vector AC. Okay, it is not CA, it is AC. Okay, so this is known as triangle law of vector addition. All right. Now we are moving on to the next topic. Then multiplication of a vector by a scalar. That is, if you are multiplying a vector with a scalar component, take it as lambda, then you multiply each component with lambda. Okay, lambda a1 into I plus lambda a2 into j plus lambda a3 into k. Okay, now how will you find out vector joining two points? How will you find out if you are given 2 points? Then you consider the position vector of those 2 points and then you subtract. Then you will get the vector joining that 2 points, right? Now, moving on to our next topic. So this is section formula. That is how you can find out the position vector of a point P when this point P divides a line AB in the ratio internally as well as externally in the ratio L is to M. That is given here. That is internally if a point P is dividing AB in the ratio L is to M, how will you find out the position vector of that point P, OP? That is equal to LB plus MA. M into vector A divided by L plus M. If that point P is dividing the line externally in the ratio L is to M, then what is the formula to find out the position vector OP? Vector OP is equal to L into vector B minus M into vector A by L minus M. And if it is the midpoint, okay, that is if the point P is dividing the line in the same ratio, or they are dividing this that is 1:1. If the point P is dividing equally the line AB, then we can find out the midpoint of that vector AB. That is the position vector of OP is equal to, it is nothing but vector B plus vector A by 2. And what is this vector B and vector A? That are the position vectors of the point A and B respectively. Divided by 2 will give you the position vector of the midpoint of that vector. All right. Now moving on to the next topic. So this is an important concept, which is dot product of scalars. So how will you find, what is the difference between dot product and this cross product? One is scalar product and one is vector product. That is, if you are getting a scalar quantity when you multiply two vectors, such product is known as a scalar product or dot product. And when you multiply two vectors and again you get a vector quantity, where you get a vector, then it is known as a vector product or cross product. Okay, so these are some of the important properties of scalar product. I hope everybody know all these things. A dot B is equal to AB cos theta. Okay, and we know A dot B will be a vector A dot B will be a real number. It will be a scalar number. Okay, and you know how to find out the dot product of the vector. You do multiply the corresponding. Okay, A1 into B1. First you add. First you find the product. Then you add with A2 into B2. Okay, then you add with A3 into B3. So that is given in the next step. Okay, that is how to find out the dot product of two vectors. Then what is projection of vector A on B? It is nothing but vector A dot B divided by vector B. Okay, if projection of A on B is asked, then the denominator will be magnitude of vector B. Okay, the second vector. If projection of vector B on A is asked, then the denominator will be on A, right? So it will be the magnitude of vector A. So it is A dot B, vector A dot B by magnitude of vector A. Alright, now moving on to the next one. The angle between vector A and vector B is cos theta. So vector A dot vector B is equal to magnitude of vector A into magnitude of vector B into cos theta, that we have studied, right? So from that you will get cos theta is equal to A dot B by magnitude of vector A into magnitude of vector B. Okay, and when magnitude vector A is perpendicular to vector B, we can say that A dot B is equal to 0. Okay, when vector A is parallel to vector B, their corresponding ratio will be equal to 0. Then I dot I, j dot k and k dot k, the value will be equal to 1, isn't it? And vector A dot vector A is equal to magnitude of A square. A dot B is equal to B dot A. A plus B into A minus B can be written as magnitude of A square minus magnitude of B square. And now the next topic is vector product. Okay, cross product of vectors, that is magnitude of vector A into magnitude of vector B into sine theta n cap. Okay, theta is the angle between vector A and B, and n is a unit vector that is perpendicular to both vector A and B. Now, moving on to its property, we know A cross B is a vector perpendicular to vector A as well as vector B, and magnitude of vector A cross vector B. So that will give you the area of parallelogram with adjacent sides vector A and vector B, isn't it? So half into determinant of A cross B gives the area of triangle with adjacent sides A cross B. Half into A cross B will give you the area of a triangle, and A cross B will the determinant of A cross B gives the area of a parallelogram. All right. Now they have given you how to find out the cross product of two vectors. It is determinant of I, J, K, A1, A2, A3, B1, B2, B3. Alright. And what is this A1, A2, A3? It is the components of the first vector, and B1, B2, B3 are the components of the second vector. Okay. And this is the other property, unit vector perpendicular to A and B is A cross B divided by magnitude of A cross B. And A cross B is equal to, we can say that, minus B cross A. Then A cross B plus C is equal to A cross B plus A cross C. Okay, lambda into A cross B can be written as lambda into vector A cross B, or A into lambda vector B. And A cross A is equal to 0. These are all also important. Okay, I cross I, J cross K, and K cross K is 0. These properties also important in this chapter. Now we'll directly move on to questions. Okay, so while doing the question, we'll discuss these concepts in more detail. Okay, so which of the first question is, which of the following measures are vectors? Okay, so they have given you four options. You have to identify the vector quantity. Okay, so what is the difference between a scalar quantity and a vector quantity? Scalar quantity has only magnitude, whereas vector quantity has both magnitude as well as the direction, right? So you have to choose a vector quantity from the given option, which means the quantity that has both magnitude and direction, right? So you consider the first option, 1000 centimeter cube. 1000 centimeter cube. It is a it is a scalar quantity, isn't it? Does that depends upon the direction? It has just a measure. Okay, it has just magnitude. So it is a scalar quantity. So we can eliminate that one. Now consider the second one. It is speed, right? 30 kilometer per hour. It is speed, which means it is a scalar quantity. Does speed depends upon the direction? No. And now the third option, C, is 10 gram centimeter per cube. That is also a scalar quantity, isn't it? And what about D option, 20 meter per second towards north? Okay. Here you can see that it has magnitude as well as direction, which is the direction they have clearly mentioned, that towards north. Towards north means the direction is mentioned there, and magnitude is 20 meter per second. So it has both magnitude and direction. So which is the vector quantity in that first question? It is nothing but option D, 20 meter per second towards north. Okay, so this is our answer. All right. Now, moving on to our second question. Which of the following measures are scalar? Again, you have to identify the scalar vector quantity from this. You can see that 10 Newton. Newton means it is a unit of force. Okay, unit of force. And force, we know it is a Vector quantity, because in force the direction is important, isn't it? So force is a vector quantity, so its Newton, its unit is Newton. So this one, option A, is also a vector quantity. And what about C? Work done. Work done. Work done, it is a product of force as well as displacement, right? It is a product of force and displacement. And we know it is dot product of force and displacement. When you do a dot product, you will get a scalar quantity. So which means work done is a scalar quantity. Okay. It is a product of force and displacement. Okay. Okay, so this is a scalar content. Fourth option, we clearly know that this one, velocity. Velocity is definitely a vector quantity because it depends upon the direction, isn't it? And now we are moving on to our third question. So, which of the following is true? You have to identify which among the following options are true. Vector A and minus vector A are collinear. Is that true? And for that, you have to know what is collinear vectors, isn't it? Collinear vectors are the vectors that are parallel to each other, isn't it? The vectors that are parallel are known as collinear vector. So, what can you say about vector A and minus vector A? And what is this minus vector A? It is nothing but the negative of the vector A. Right, it is the negative of the vector A. It is the negative of the vector A. Okay, so this is our vector A, and minus A is negative of that same vector. Okay, it will have the same magnitude, but it will have different direction. That is what a negative vector means. Okay, it will have the same direction but in opposite direction. So if this one, you consider this one as vector A, okay, if this one as vector A, then what will be minus A? The same vector but in the opposite direction. Okay, but in the opposite direction. So that is minus vector A. Okay, that is minus vector A. All right, so what can you say about vector A and minus vector A? This is vector A and this is minus vector A. They will be collinear, right? They will be parallel to each other. And two collinear vectors are always equal in magnitude. Two collinear vectors are always equal in magnitude. Is that true? Two collinear vectors are always equal in magnitude. Is that necessary? Is that necessary? If you consider a vector like this, and then you consider a vector like this, okay? So these are clearly parallel to each other, right? These two vectors are clearly parallel to each other. Are these, does these vectors, let this be A and this be vector B. Okay. Does that have the same magnitude? No, isn't it? It is clearly twice of the first vector. So it is not necessary that the collinear vectors have the same magnitude. Okay, now the third option is two collinear vectors are always the same direction. No, clearly this is an example. These they are vector A and the negative of the vector A are collinear, but they don't have the same direction. They have just opposite direction, right? And the fourth option is two collinear vectors having the same magnitude are equal. That is also not true, right? Here, these have the same magnitude. They are collinear vector. They have the same magnitude. Can you say that these vectors are equal? No, because their direction is opposite. Two vectors are said to be equal. When can you say that two vectors are equal? When their magnitude as well as the direction are equal, right? Here, only the magnitude are equal. The direction of both the vectors are different. So we can say that the option D is also wrong. So all the three options are wrong. So we can say that only the first option is true. Vector A and minus vector A are collinear. Okay, now moving on to our next question. The values of x, y and z, so that the vectors vector A equal to xi plus 2j plus zk and vector b is equal to 2i plus yj plus k are equal. When can you say that two vectors are equal? When their corresponding scalar components are equal, isn't it? When their corresponding scalar components are equal, we can say that two vectors are equal. So here, what is the component of the unit vector I for the vector A? For the vector A, it is x, right? For vector B, it is 2. So x should be equal to 2. Okay, now what is the component of j for the vector A? It is 2, right? So 2 is equal to corresponding j component of vector B should be equal. So it is y. So we got y is equal to 2. And what is the scalar component of unit vector k? It is z, isn't it? Z. Z should be equal to the scalar component of unit vector k in vector b. Unit vector of k in vector b is 1. So z should be equal to 1. So x equal to 2, y equal to 2 and z is equal to 1. Okay, option C is right. Option C is right. Alright. Now next one in vector addition, which of the following is not true? You have to find out from the four option which is not right. Okay, that is which is wrong. So you know triangle law of vector addition, right? Triangle law of vector, according to triangle law of vector addition, if you are given 3 points of a triangle, then if you add two sides of this triangle, okay, like this AB, vector AB plus vector BC, then you will definitely get vector AC. So this is known as triangle law of vector addition, right? Vector AB plus vector BC, that is equal to vector AC, right? So this can also be written as vector AB plus vector BC. Okay, vector BC minus vector AC. I can take this AC to left side, right? So minus vector AC is equal to vector 0, isn't it? So from this you can say that option B is true. Alright, option B is true. Now you consider this one itself, the first one, okay? Instead of AC, I'm going to write minus A. Is that true? Is that true? We can write like that, isn't it? AB plus BC is equal to, and we know AC, vector AC can be written as negative of vector CA, isn't it? Isn't it true? Negative of vector AC and CA will have the same magnitude. The difference is that the difference of AC and CA. What is the difference of AC and CA? AC means it is the line, directed line from A to C. And what about CA? It is a directed line from C to A. And if you put a minus there, what is happening there? If you put minus to CA, which means the direction changes, isn't it? From C to A. It was actually from the direction was actually from C to A. And if you put a negative there, it will become negative of CA means negative of a vector means the direction is reversing. So the direction will become from A to C. Isn't it? The direction will become from A to C. So vector AC can be replaced by minus of vector CA. Okay, so this can be written as minus CA, minus CA. Okay, so AB plus vector AB plus vector BC plus vector CA is equal to vector 0. Okay, it is equal to vector 0. So we can say that this one is also true. Okay, first option is also true. And now consider the option D. Consider option D. Okay, so so we are going to consider option D. Okay, so consider a triangle ABC. Okay. So in this, you can see that it is AB minus EB plus EA equal to 0. What you have to do is that you have to check whether this one satisfies the triangle law of vector addition. Okay, in any manner, if you rearrange all these things, you will get the triangle law of vector addition or not. Okay, so that's what I'm going to check. So I'm going to consider first the vector CA. What is vector CA? CA is like this, right? CA, then plus vector AB. You rearrange this one like this. Okay, vector CA plus vector AB minus CB, okay, is equal to 0. Okay, this can be rearranged in that way also, isn't it? So this is CA, vector CA, and this is vector AB. Okay, this is vector AB, and according to triangle law of vector addition, CA plus AB. Okay, vector CA plus vector AB is equal to, it is vector AB is equal to, we know it is CB, right? It is CB, right? That means it is like this. It is AB. This one is direction like this. Okay, so CA plus AB is equal to, we know it will be from C to B, right? It is equal to C to B, CB. So this can be written as, this can also be written as CA, vector CA plus vector AB minus vector CB minus vector CB equal to 0. Okay, so this one also satisfies a triangle law of vector addition. Okay, let's see what happens to this vector AB plus vector BC minus EA equal to 0. Is that true? No, we have already found out that it is plus CA because vector AB plus vector BC is equal to, we can write it as minus vector CA, right? So minus CA, if you take it to the left side, it will become plus CA, right? So we can say that clearly the option C is wrong. Option C is wrong. Now, moving on to our next question. A unit vector in the direction of vector A equal to 2i plus 3j plus k. So you are given a vector A, that is 2i plus 3j plus k. You have to find out the unit vector in the direction of that vector. Okay, in the direction of that vector. How will you find out a vector in the direction of that vector? A unit vector. That should be a unit vector also. It is nothing but unit vector in the direction. Unit vector in the direction of vector A is equal to nothing but vector A by magnitude of vector A. Okay, it is vector A by magnitude of vector A. And what is this vector A? This 2i plus 3j plus k. 2i plus 3j plus k divided by root of, how will you find out the magnitude of vector A? It is root of x component plus that's square of the x component plus square of the y component plus square of the z component, right? So what is the x component here? It is 2. So 2 square. And what is the y component here? It is 3. So it is 3 square. And what is the z component? It is 1. 1 into k is k, right? So it is 1 square. So this will give you the unit vector in the direction, isn't it? It is 2i plus 3j plus k divided by root of 2 square is 4. Isn't it? 4 plus 9 plus 1. So this is equal to 2i plus 3j plus k divided by root 14. Divided by root 14. Okay. I hope this question was clear to you all. Now we are moving on to the next question. That is the direction ratios of the vector A equal to I plus j minus 2k. So you are given a vector A. You have to find out the direction ratios of that vector. How will you find out the direction ratios of the vector? It is nothing but the x, y and z component of a vector. That is the direction ratio, isn't it? So the x component of I is 1. J component is 1 and the the z component is minus 2, isn't it? So the direction ratios of that vectors are nothing but the scalar components, isn't it? The scalar components here you can clearly see the scalar component is 1, 1 and minus 2. So which is the option? 1, 1 and minus 2. So let's make this one as plus 1. Okay, it is 1, 1 and minus 2. Okay, 1, 1, minus 2. So option B is right. So actually the options printed here has some mistake. So option B change it into plus 1. So it is 1, 1 and minus 2. So option B is the right answer. Alright, option B is the right answer. Now, the next question is direction cosines of the vector A equal to I plus 2j plus 3k. Okay, vector A is I plus 2j plus 3k. You have to find out the direction cosine. So, how will you find out the direction cosine? The first direction cosine is the scalar component divided by scalar component of I is 1, right? So, 1 by root of x square plus y square plus z square, right? So what is x here? First you write x, y, z from this. So vector A is given here. What is the scalar component? X equal to 1, y equal to 2 and z is equal to 3. Okay, so what is the direction cosine? What will be the direction cosines? First one will be 1 by, okay, 1 by root of 1 square plus 2 square plus 3 square. Actually, it is x by root of x square plus y square plus z square. This is the one direction ratio. Then y by root of x square plus y square plus z square, and z by, I'm sorry, it is direction cosines. Okay, by root of x square plus y square plus z square. So these are the direction ratios. So first one will be 1 by root of 1 square plus 2 square plus 3 square. That is equal to 1 by root of 1 plus 4 plus 9, isn't it? So this is equal to 1 by root 14. 1 by root 14. Isn't it? Now, the second component is y equal to 2, right? So this will be 2 by, again, it is root 14. Isn't it? Same answer. Root of denominators are same, right? Root of x square plus y square plus z square. So we can, we'll get it as 2 by 14. And what is this third component? It is 3. So what is the third one? It is 3 by root 14. So what are the direction ratios? 1 by root 14. 2 by root 14, 3 by root 14. So option D is the right answer. Option D is the right answer. Now moving on to the next question. The direction ratios of the line joining the points A 1 2 minus 3 and B minus 1 minus 2 1 directed from A to B. So they have given the direction, it is from A to B. So you have to find out vector AB, isn't it? Vector AB. So they have given the points A as 1 2 minus 3 and B is the point minus 1 minus 2 1. You have to find out the direction ratios. You have to find out the direction ratios of which line joining the points AB. Okay, that line should join the points AB, and which is the direction. It is directed from A to B. That is also given there. So it is nothing but vector AB. Okay, it is nothing but vector AB. How will you find out the vector AB? First, we need to find out the vector AB, right? Then only you can find out the direction ratio. So, how will you find out vector AB? Vector AB is nothing but position vector of B minus position vector of A, right? It is position vector of B minus position vector of A, isn't it? So, what is the position vector of B? It is minus I minus 2j plus k. Minus I minus 2j plus k minus what is vector OA? What is vector OA? It is equal to I plus 2j, I plus 2j minus 3k. I plus 2j minus 3k. So this is equal to minus I minus 2j plus k minus I. I'm sorry. Okay, is that right? The position vector of B and position vector of A, it is minus I minus 2j plus k minus I plus 2j minus 3k. Okay, that's right. Now, how will you do? How will you subtract two vectors? You subtract the corresponding components, isn't it? So first you consider the components of unit vector I. It is minus 1 and 1, isn't it? Minus 1, minus 1, minus 1 into I, isn't it? Just a minute. Okay, now you add, next you subtract them y component, right? So it is minus 2 minus 2, isn't it? Minus 2 into j plus 1 minus 3k. Isn't not 3k, it is minus 3. 1 minus 3 into k. Okay, it is minus 1, then minus 2, 1 minus 3. Okay, you can do it in a single step also. You don't need to write all these steps because it is 1 mark question. You can do it directly also. Okay, since I'm doing it for the first time, I'm explaining it explaining it by step. All right, so you can directly subtract it and find out the answer. Okay, that is -1 -1. You can do it like this: -1 -1. Then you'll get the I component, right? Then -2 -2, then 1 -3. That's all. Okay, so this is equal to -2i uh, -4j, isn't it? -2 -2 is -4j. Then plus 1 -3 is 4k, right? It is 4k. So what are the scalar components of this vector? The scalar components of the vectors are -2, -4 and +4. -2, -4 and +4. So which is the option? Which is the right option from this? Which is the right option from this? It is -2, -2, -4, and 4 are the scalar components of vector AB. These are the scalar components of vector AB. So this is the direction ratios of the vector AB, isn't it? Scalar components are nothing but the direction ratios of the line, isn't it? So -2, -4 and 4, which is the option? -2, -4 and 4. C is the right option. C is the right option. All right. Now we are moving on to the next question. The magnitude of the vector 1 by root 3 into I plus 1 by root 3 into j minus 1 by root 3 into k. How will you find out the magnitude of a vector? How will you find out the magnitude of vector? It is nothing but root of x square plus y square plus z square. This is the magnitude, right? So let this be vector A. Okay, let this be vector A. Then magnitude of vector A is equal to, and what is this x, y and z? X is equal to 1 by root 3. Y is equal to 1 by root 3 and Z is equal to -1 by root 3. Z is equal to -1 by root 3. So this is equal to root of 1 by root 3 the whole square plus 1 by root 3 the whole square plus Z value is -1 by root 3. -1 by root 3 the whole square. Okay, so that is equal to root of 1 by 3 plus 1 by 3 plus 1 by 3. So that is equal to root of 3 by 3. That is root 1. That is equal to 1. That is equal to 1. So what is the value here? Option D. Option D. You know, root 3 into root 3 is nothing but 3, isn't it? So that's why I did it so fast. So what is the magnitude of the given vector? It is nothing but 1. Okay, so I have picked most important questions from this chapter. Okay, so these questions are repeatedly asked for your exams. So you should definitely study all these multiple choice questions before going to exam. All right. Now, the value of x for which x into vector I plus vector j plus vector k is a unit vector. That is, they are asking about unit vector. So you have to know what a unit vector is, isn't it? What is a unit vector? It has magnitude 1. It has magnitude 1. So this should be a unit vector. Means this should have magnitude 1. That should have magnitude 1. And here you have given that I plus j plus k. What is the magnitude of I plus j plus k? I plus j plus k. What is the magnitude? You can find out the magnitude, right? Because x equal to 1, y equal to 1, and the z component is also equal to 1. So what is the magnitude? It is 1 square plus 1 square plus 1 square. It is root 3. Right? 1 plus 1 plus 1, it is 3, right? Root 3 is the magnitude of this vector. So if you put x equal to 1 by root 3, what happens? What happens? 1 by root 3 into root 3. If you find out the magnitude of this vector. Okay, if you find out the magnitude of this vector, then it will be 1 by root 3 into root 3, right? So that is equal to 1. So the magnitude of the vector will become 1, right? So which value should we give for x? It is nothing but 1 by root 3. It is nothing but 1 by root 3. Okay. Now moving on to our next question. The unit vector in the direction of vector A plus vector B, where vector A is equal to 2i minus j plus 2k and vector B is equal to minus I plus j minus k. Okay, so you are given two vectors, that is 2i minus j plus 2k, and vector B is equal to minus I plus j minus k. Minus I plus j minus k. You have to find out the unit vector in the direction of vector A plus vector B. So vector A plus vector B, how will you do vector A plus vector B? You have to add the corresponding components, isn't it? So the I component is 2 and minus 1, isn't it? So you have to add it 2 plus minus 1 into I, then plus minus 1 plus 1, isn't it? Minus 1 plus 1 into J, and then the K component is 2 minus 1 into K, isn't it? That's how you add two vectors, that is A plus B. All right. So this is equal to 2 minus 1 is 1. So this is 1 into I is I. Second one, this one is 0. So J component is not there for that vector. 2 minus 1 is 1. So this one into K is equal to K. So I plus K is our vector A plus B. A plus B is the vector I plus K. Okay, now you have to find out the unit vector in the direction of this vector. How will you do this? We have already done this type of question, right? Unit vector in the direction of vector A plus vector B is equal to, again it is nothing but vector A plus vector B divided by magnitude of vector A plus magnitude of vector B. Okay, so this is our formula. So vector A plus K, A plus B we have already found out, it is nothing but I plus K divided by magnitude of I plus K divided by magnitude of I plus K. And what is this magnitude of I plus K? Magnitude of I plus K, it is equal to root of 1 square, isn't it? The component of scalar component of I is 1, scalar component of k is also 1. So it is root of 1 square plus 1 square, that is equal to root 2, isn't it? Root 2 is the magnitude of that vector. So this is equal to vector I plus vector k divided by root 2. Vector I plus vector k divided by root 2. So which is the option? B option is right. Vector I plus vector k divided by root 2 is the unit vector in the direction of vector A plus vector B. Alright, now moving on to our next question. The position vector of the midpoint of the vector joining the points P 2, 3, 4 and Q 4, 1, minus 2. So you are given 2 points. It is 2, 3, 4 and 4, 1, minus 2. You have to find out the position vector of the midpoint of the vector joining the points. Okay. So the points are P and Q. Okay. So how will you find out the position vector of the midpoint? First, you can write the position vector of OP. Okay. That is equal to 2i plus 3j plus 4k. I hope everybody knows how to write the position vector and all. So this is the point, right? 2, 3, 4. These are the components. So you will write it as 2i plus 3j plus 4k. Okay. And what is OQ? Vector OQ, position vector of OQ. The points are 4, 1, minus 2. So how will you write it? 4 into I cap plus 1 into j is j itself, right? So j cap plus minus 2 into k cap. Okay, so this is 4i plus j minus 2k. Okay, that is the position vector of OQ. Now you have to find out the position vector of the midpoint. Okay, there will be a midpoint of this vector. How will you find out the position vector of midpoint? Position vector of midpoint is equal to, we have already studied it, right? This vector B plus vector A by 2. And what is this vector B and what is this vector A? It is the vector, position vector of the second point, that is there will be a direction for the vector, right? It is, if it is defined from P to Q, then you have to first consider the position vector of the point Q. Okay, so that is OQ here. I'm really sorry. It is of midpoint, right? Midpoint means it is, you have to add it, right? You have to add two vectors, isn't it? I'm really sorry. I'm really sorry. So this is actually We have section formula when a point divides internally, externally, and midpoint also, isn't it? For midpoint, it is nothing but I have already explained it. I think I have explained in the introduction part. Here you can see. Okay, here you can see that internally this one LB plus MA by L plus M. Okay, externally LB minus MA by L minus M, and here you can see that it is a midpoint, then it is just adding two vectors and then dividing by 2, adding two vectors and then dividing by 2. Okay, so the position and all is not important because we are adding two vectors, right? Here you can write this one as vector OQ plus vector OP divided by 2. Okay, so this is equal to 4I plus J minus 2K plus 2I plus 3J plus 4K. Okay, so these are the vectors. Then divided by 2. Now add the components of the I. They are 4 and 2. So 4 plus 2 is 6I. Then 1 and 3. 1 plus 3 is 4. So it is 4J. Then minus 2 plus 4. Minus 2 plus 4 is plus 2K. Plus 2K divided by 2. Plus 2K divided by 2. And how will you do this? You have to divide each component with 2. Divide each component with 2. So 6 by 2 is 3. So it is 3I. Then 4 by 2 is 2. It is 2J. Then 2 by 2. 2 by 2 is 1. So this is equal to K. Okay. So 3I plus 2J plus K is the position vector of the midpoint of the vector. Alright. Now, moving on to our next question. The position vector of a point which divides the join of points with position vector 3a minus 2b and a plus b externally in the ratio 2 is to 1. Here option A is the right answer. Okay, I forgot to mention that. Now moving on to our next question. So here also we have to find out the position vector of a point that divides a line, but it is not equally dividing. It is dividing in the ratio 2 is to 1. In the previous question we have seen that that particular point is dividing the line equally. That's why that point became the midpoint, isn't it? Since it is a midpoint, it divides the line in the we can say that it divides equally, isn't it? It divides the line equally or in the same ratio, 1 is to 1 ratio. Here, the point is dividing that particular line in the ratio 2 is to 1. That too externally. Okay, that point is dividing the line externally in the ratio 2 is to 1. So what was the formula? It was L into vector B minus M into vector A divided by L minus M. Isn't it? And what is this L and M? L is to M is equal to, it is given here, it is 2 is to 1. It is the ratio. L and M are the ratio. Okay. So L is to M, it is given here as 2 is to 1. And this particular point is dividing the line externally in the ratio. Externally means it will be LB minus MA by L minus M. If it was internally, it will become LB plus MA by L plus M. Okay, that is the difference here. Okay, and what is this vector B and vector A? Here they have directly given the vectors. It is vector A is equal to 3 into vector. Let this be capital letter A, okay? Otherwise, you will get confused. So, vector A is equal to 3A minus 2 into vector B. And vector B is equal to vector A plus vector B. Okay, vector A plus vector B. Okay, so you can change this formula as L into vector B minus M into vector A by L minus M. Alright. So this is our second vector. This is our first vector. So how will you do this? What is L? L equal to 2 and M is equal to 1. L equal to 2 and M is equal to 1. Alright. Now this is equal to 2 into vector A plus B minus 1 into vector A is 3 into vector A minus 2 into vector B divided by L minus M means 2 minus 1, isn't it? So this is how will you do this? You have to multiply each vector. isn't it? So this will become 2 into vector A plus 2 into vector B minus 3 into vector A plus 2 into vector B divided by 1. Okay, so this is equal to 2a minus 3a is minus a, and what is 2b plus 2b? It is plus 4b. So it is either minus a plus 4b, or we can rearrange this vector as 4 into vector b minus vector a. 4 into vector b minus vector a. Is there any option like that? 4 into vector b minus vector. I think there is a mistake in this question also. In the option there is a mistake. It is not 4a minus b. It is actually, let's make this option as 4 into vector b minus vector a. 4 into vector b minus vector a. So this is the right answer. All right. 4 into vector b minus vector a. Now, the value of lambda for which the vectors 2i minus 3j plus 4k and minus 4i plus lambda j minus 8k are collinear is. Okay, so you have to find out the value of lambda such that the vectors are collinear. So how can you say that two vectors are collinear when their direction ratios are proportional? Okay, when two vectors are collinear, their direction ratios will be proportional. So there are many methods to find out for the property of collinearity of two vectors. Okay, so here we are taking the proportionality of the direction ratios. Okay, in order to solve this problem, that is, if two vectors are collinear, then their direction ratios will be proportional. Okay, so what are the direction ratios of the first vector? It is 2, minus 3 and 4. And similarly, the direction ratios of the second vectors are minus 4, lambda and minus 8. These will be proportional, means that is 2 by the corresponding components are 2 and minus 4, right? So 2 by minus 4 will be equal to minus 3 by lambda, that will be equal to 4 by minus 8 if the vectors are collinear. Okay, if the vectors are collinear, those vectors will be parallel, then they will definitely satisfy this property. That is, the direction ratios will be proportional. All right, so consider this part. From this part itself, we can solve the answer, right? There is only one unknown, so we can solve it easily. So this is equal to 2 by minus 4 is equal to minus 3 by lambda. Okay, so you just cross multiply this. 2 lambda is equal to minus 3 into minus 4. That is 2 lambda is equal to plus 12. So lambda is equal to 12 by 2. That is equal to 6. Lambda, value of lambda is equal to 6. All right. Now, which is the option? B. B option is the right option. Moving on to our next question. So if I, j and k are unit vectors, then which of the following is incorrect? Okay, so you have to find out in the 4 options given there the incorrect statement. Okay, so you know I dot I, j dot j, k dot k is equal to 1. What is the reason? Because of this I dot I, we know it is magnitude of I into magnitude of I. Since it is dot product, it is the angular sine, isn't it? Dot is sine. Okay, sine theta, isn't it? This is a formula. Okay, so here we know, since this is I dot I, they are the same vector. What is the value of theta here? This will be 0, isn't it? The value of theta will be equal to 0 because they are the same vector. Same vectors have the angle 0, isn't it? So I into sine 0. And what is the sine 0? We know sine 0. I'm sorry, it is cos, okay? Really sorry, since it is dot product, it is cross. Sorry, it is cos. It is cos 0. Okay, I dot I into cos 0. What is the magnitude of the unit vector? Unit vector itself, it is 1, right? Magnitude of unit vector is nothing but 1. 1 into 1 into what is cos 0? Cos 0 is 1, isn't it? So 1. So what is the total value? I dot I is equal to 1. Similarly, j dot j also, the angle between these vectors will be 0. So cos 0 is 1. Again, the value of j dot j, k dot k, etc. will be equal to 1. So the first option is right. And what about this I dot j, j dot k, k dot I? We know I dot the vectors can be placed like this, isn't it? For easiness, that is I, then the second vector is j, and the third vector is k. Okay, so this is the direction that followed by the unit vector I, j, k, right? So the second one is I dot j. What is I dot j? What will happen if you multiply I with j? I dot j. So this will be magnitude of I into magnitude of j into cos. What is the angle between I and j? They are mutually perpendicular vector. I, j, k are mutually perpendicular vectors, isn't it? What do you mean by mutually perpendicular vector? The angle between these vectors will be 90 degree. So what is the angle between I and j? It is cos 90. The angle between I and j is cos 90. So this is equal to magnitude of I is 1, magnitude of j is 1, and what is cos 90? Cos 0 is 1. Cos 90 is 0. So 1 into 1 into 0 is equal to 0. Okay. So this is I dot j 0. Then j dot k 0. Then k dot I is also 0. So that option is also true. Now what about the fourth option? I cross j. I cross j. J cross k. That is equal to k cross I. That is equal to 1. Is that true? I cross j is equal to, we know this, magnitude of I into magnitude of j into sine theta, isn't it, into sine theta. So this is equal to 1 into what is the angle between I and j? It is sine 90, isn't it? What is sine 90? It is 1, right? So this is equal to 1 into 1 into 1. That is equal to 1. Similarly, we can prove it for jk and ki also. Alright, we can prove it for jk and ki also. We will get the same result. Okay. Now we are going to the, so D option is also right. Now we are moving on to the C option. That is I cross I. I cross I is equal to magnitude of I into magnitude of I into sine, the angle between the same vectors is 0. It is sine 0, isn't it? So this is equal to 1. This is equal to 1. What is sine 0? Sine 0 is 0, isn't it? So this is equal to 0. What is I cross I? It is actually, it is sine 0, 0. It is a scalar quantity 0. It is a scalar quantity 0. But here they have given it as a vector quantity, vector 0. So we can say that option C is incorrect. Option C is incorrect. Alright. Now we have a few more questions that we will discuss as a next session. Okay, that is you have we can discuss some more questions that carries 1 mark, which are important and that are repeatedly asked for exams. Okay, that will be discussed in the next session. Okay, I hope this session was useful to you all. Thank you.